if you are having trouble with your homework, first I would recommend go back and make sure that you've watched how to solve by factoring. So make sure that you've watched those notes. And then the homework for this evening, it is technically a review, but we definitely have upped the algebra just a little bit on some of these problems. So our first set here is just solving by factoring. So it's just making sure that you remember how to solve and before we apply to anything. So again, to get a negative 10, I'm looking at 1 and 10, or we're looking at 2 and 5. Those are my only two options. If I want to get a negative 10, then I'm going to need a negative and a positive. So there's no way that 1 and 10 are going to get me to that negative 3. If the middle number is negative, then I need the bigger of the two factors to be negative. And so factored form would be x plus 2 and x minus 5. Again, it has to equal 0 if it's an equation. So x should be equal to either negative 2 or positive 5. Remember, we set each one equal to 0, so x plus 2 equals 0, and we would subtract. So that's where that came from. Right? Or I've got, and I ran out of room, sorry, x minus 5 equals 0, and so we would add 5 on both sides, and there's the x plus 5. All right, as we look at number 2, okay, again, we're going to remember it has to equal 0. It is an equation. I do have x squareds, x's, and 16s. That's fine, but it has to equal 0. So your first step is going to be, you've got to move everything to the other side. All right, so we're going to get rid of a 10x and we're going to add a 16. So x squared minus 10x plus 16 is now going to equal 0. All right, so it needs to be, again, ax squared plus bx plus c form has to equal 0. And then we're going to check out that c. So in order to get a positive 16, both are positive or both are negative. 16, I can have 1 and 16. We can have 2 and 8, or we can have a 4 and a 4. Now, in order to get positive 16, they're either both positive or they're both negative. That's the only way to multiply and get a positive value. So as I look at my terms out here, 1 and 16 are never going to get me a 10, right? It's either a 17 or a 15. That's not going to work. But 2 and 8 will, right? If I had negative 2 and negative 8, I could go ahead and get to that negative 10. So factored form is going to be x minus 2 and x minus 8. Right, we set each one of those equal to 0, so x minus 2 equals 0. So one solution is that x equals 2. And then if I set, Sorry, couldn't find the whiteout. There we go. All right, so we have x minus 8 equals 0. And if we add that 8 on both sides, x should be equal to an 8. And again, with the algebra, we don't have to check it. We don't have to check it, right? Because it's just where does it cross? So on our last one here, again, I've got an x squared minus x. That's not a problem, but it has to equal 0. So we're going to go ahead and move that 20. X squared minus x minus 20 is now going to be equal to 0. So it's in the correct form. It's an equation, and it equals 0. So we're good to go. Now, in order to get a 20, I can have 1 and 20. I can have a 2 and a 10. Or I can have a 4 and a 5. I'm noticing that 20 is negative, which means I have a positive and a negative value. Well, 1 and 20 are never going to get me back to a negative 1, so that's not going to work. 2 and 10, again, I can get a 12 or an 8 out of that. That's not going to work. But 4 and 5 could, right? If I added, I'd get a 9, but if I subtracted, I could get a 1. Again, there's applied. If I want a negative, then the bigger factor needs to also be negative. And so factored form would be x plus 4 and x minus 5. And again, that equals 0. So either x plus 4 equals 0, which if we move the 4, x would be negative 4. Or x minus 5 equals 0. And again, if we add that 5, x would be equal to a 5. Either of those would work. All right, as we move on, we're going to look at number 4. You're given a parallelogram. So again, you know several things as soon as they tell you parallelogram. Opposite sides are going to be parallel. Opposite sides are going to be congruent. Diagonals are going to bisect each other. But remember, angles do not get bisected. The angles are going to be alternate interior. All right? But you will know that the consecutive angles will be supplementary. That would be same side interior. So we're going to notice A to C is going to be an 8x minus 14, and e to c is a 2x plus 11. Well, again, we know that on our diagonals that they bisect, which means that where they meet, all right, it's going to cut each set in half. So I know that BE is the same as E to D, and I know that AE is the same as E to C. Well, if E to C, if this one is 2x plus 11, well, then so is the other side, right? They would have to be the same thing. And I know that the whole thing is equal to 8x minus 14, right? So I know that A to E, that segment, plus E to C has to be equal to the entire thing. And so then it's just a matter of substitution. So 2x plus 11 plus another 2x plus 11 has to be equal to 8x minus 14. And then it's algebra. Now, at this point, you're welcome to solve for the variables. Like, you can move the x's around, you can move the numbers around. I like to keep my variables positive, so I'm going to move that 4x. So now 22 is going to be equal to 4x minus 14. I'm going to add that 14. Sorry. So 36 is going to be equal to a 4x. And then if we divide, 9 should be equal to x, which is what they wanted us to solve for. Okay, if we're not sure, we can always substitute that back in. So if I take 9 and I plug it in here, right, 2 times 9 plus an 11, that would get me an 18 plus 11. That's going to get us a 29. So if I were to double 29, right, I would get 58. If I plug my 9 in up here, 8 times 9 would get us 72. 72 minus 14 is also 58. So we know that it works. Okay, number 5. This time they give us a rectangle. Now again, a rectangle has all the properties of a parallelogram, but we also know that the diagonals, not only do they bisect, but they're congruent. So AE is the same as E to C, is the same as B to E, and is the same as E to D. We also know that rectangles have right angles at all of the vertices. All right, so lots and lots of things that get added when we start looking at a rectangle. So if I look at the first one, the measure of angle B to C to D. Well, again, that's going to be 90 degrees. That's a right angle. Then I'm going to look at A, B, D. All right, so I want this guy right here. What we want to remember, if it's a rectangle, then I know that AB is parallel to DC, and if I cut it with a transversal, then we've got alternate interior angles. So ABD is the same as BDC. They're alternate interior. All right, our next one, the measure of angle CBE, C to B to E. All right, so that would be the other side of it. If I switch, that would be this side right here, CBE. We know that the whole thing is 90. So if we take 90 and get rid of 16, that should leave us with 74. If I look at ADE, ADE would be this side. So again, I can use the same reasoning, or I can recognize that these are alternate interior as well. But we've got ADE, that one is also going to be 74 degrees. Then we're going to ask about AEB. Well, AEB is this guy right in here. I'll put 3 on that one. Now, diagonals in a rectangle they're not perpendicular, so it's not 90 degrees. But hopefully you're noticing you do have some triangles in here, right? And not only do I have triangles, I have isosceles triangles. And so what hopefully we're going to remember is that I have a base angle theorem, that if I know that these two sides are the same, then these angles have to be the same. So if this is 16, so is this one. Which means in order to find that missing angle, right, they're 180 degrees in a triangle, and if we get rid of the two 16s, we should wind up with 148. All right, and then finally, we wanted D to E to A. So this one. Now again, we could use the same reasoning, right? That if this is 74, so is this one, because again, I've got another isosceles triangle. You could also recognize that the angle here in green is a linear pair with the one in blue, right? So if this is 148 to find its linear pair, I could take 180 and get rid of 148, and that should wind up with 32 degrees. So any of that reasoning would work. All right, as we look at 6, you've been given a parallelogram. So again, we know opposite sides are parallel, or we all know opposite sides are congruent, and we also know that consecutive angles are going to be supplementary. So let's go ahead and start with the sides, because I'm noticing that P to S should be the same as Q to R. And I'm noticing we've got the squareds in here. So we're going to set up an equation. X squared minus x has got to be equal to 13x plus a 15. Opposite sides have to be congruent. Now, if I have an x squared, I've got to have it equal to 0 for 1. It is an equation, but I also have to have that hopefully ax squared plus bx plus c. So let's go ahead and move that 13x, and we'll just do it a step at a time so you see where everything went. So x squared minus 14x is going to be equal to a 15, and then we'll go ahead and move the 15. Okay, so once you have it, so it's ax squared plus bx plus c, and it equals 0. Once that's done, then we're going to factor. So to get a 15, right, I can have a 1 and a 15, or I can have a 3 and a 5. I'm noticing that to get a negative, I would need a positive and a negative number, which means I'm really going to subtract. So of my two options, if I want a negative 14, it's got to be the 1 and the 15. And if I want the number in the middle to be negative, then the larger of the two factors has to be negative. So I would have x minus 15 and x plus 1, and that's going to equal 0. So if we solve each of those, x minus 15 equals 0, or x plus 1 equals 0, x is going to be equal to a positive 15, or x is going to be equal to a negative 1. Algebraically, both of those solutions are true. But because we're applying it to distances and to lengths, we actually need to check that. Okay, so we're going to check to make sure it works. So if x is 15, right, then I would plug it in here. So I would have 13 times 15 plus another 15. Oops, sorry, I wrote 5. That should come out to 210. And if I check it on the other side, I would have 15 squared minus 15, and that is also 210. And so that one works. I get a positive value. They happen to be the same. It's perfect. Then I'm going to check what happens if I have x equals negative 1. Does that one work? So we do the same thing. So I could take 13 multiplied by negative 1 and add 15. And that's a 2. So far that works just fine. Now I check it on the other side. If I take negative 1 and square it, and I subtract a negative 1, you need to be really careful with your signs. Negative 1 squared is really positive 1, and negative is another positive, and 1 plus 1 is indeed a 2. So both answers work here. So x can be 15, or x can be negative 1. Either one of those work. Then we're supposed to find the y value. So we found x, now we're going to find y. So I'm noticing that y happens to be with these angles, all right? And in a parallelogram, I've got parallel lines. If they're cut by a transversal, these are really same side interior, which means they need to add to 180. I'm running out of space. Here we go. So 4y plus 7 plus 10y minus 37 has to be equal to 180 degrees. So we're going to combine like terms. 14y minus 30 is going to be equal to 180. And then if we add 30, 14y is going to be equal to 210. And if we go ahead and divide, y should be equal to 15. And we can absolutely substitute that back in, but again, it's a positive value, so I have no reason to doubt that it would work. All right, and then our last one on the page, on this side, excuse me, the coordinates, given the coordinates, prove whether it's a parallelogram, rectangle, or neither, and we're supposed to use our slopes. Now, again, I sketch a picture just so I can see what sides line up, but remember that your picture doesn't prove anything. You have to do the math. So S is going to be at 1, 5. That would put S here. T is going to be at 10, 7. 10, 7. U is going to be at 14, 1, so I'm going to extend just a little bit. 10, 11, 12, 13, 14. So here's U, and V is at 3, negative 1. And there's V. So give or take, it looks something like this. Now it doesn't exactly look like it should be one of our shapes, but again, I could be, have lousy drawing skills. That's perfectly fine. So if I want to use, if I want to prove, it's definitely a quadrilateral. It has 4 sides, all my sides meet, so it could be a quadrilateral. If I want to prove parallelogram or rectangle, I've got to prove that my slopes are going to be parallel. So if I look at the slope of, let's say, S to V, remember your slope formula is change in Y over change in X. So S and V, I'm looking at these guys. It does not matter which point you start with, just be consistent. So if I start with S, I would have 5 minus negative 1. And if I started with S for Y's, I start with S for X's. So then I would have 1 minus 3. So I'm going to get 6 over negative 2, and so I'm going to get a negative 3. Now if I check T to U, so the slope of T to U, that would be these guys. Again, it doesn't matter which one I start with. So if I start with T, I would have 7 minus 1 over, if I started with T on the top, I have to start with T on the bottom. So I'll have 10 minus 14. Well, that's going to get me 6 over negative 4, which is going to be a negative 3 halves. These are not the same, which means these sides are not parallel. And if those aren't parallel, then it cannot be a parallelogram and it cannot be a rectangle. Okay, so since SV is not parallel to TU, the shape is a quadrilateral. Now, as we move on, right, we might discover that it's one of our other shapes, but for now, it is definitely not a parallelogram or a rectangle.